Good afternoon, everyone. Today isn't about specific product, it's about perspective. We'll explore how browsers and devices already reveal more about themselves than most people realize, and how that can help fight fraud if we interpret it in context. Because the real challenge in anti-fraud isn't collecting data, it's deciding what it means. My name is Makarský. I'm Director of Engineering at Fingerprint, and I'm responsible for developer experience, integrations, and research. This talk is structured like a story. We'll start by defining a few key terms, then dive into real-world problems. From account takeovers to card testing, payment fraud, and review abuse, and finish with a short demo showing how we can act on these signals in real time. Before we begin, I want to acknowledge something important. Some of the same techniques we'll discuss, collectively known as fingerprinting, are also used for tracking and personalization purposes. Targeting ads, optimizing conversions, recommending products, etc. That's a very different use case, and it's beyond the scope of this talk, and I'll focus just on anti-fraud. Let's start with fingerprinting. When I say fingerprinting, I don't mean tracking per se. I mean identification and environment contextual data. It's about combining ordinary system details that on their own mean nothing, but together uniquely describe an environment. Individually meaningless, but together they form a consistent signature. It's how a site can recognize the same browser even after cookies are cleared, like a digital handshake that says, "I've seen you before." What do we mean by device browser identifier? This is the practical side. It's what most anti-fraud systems actually use. A stable device or browser identifiers help us separate returning users we trust, first-time visitors, and potentially dangerous anomalies, while reducing friction for people you already trust. So, how are these identifiers created? They've evolved a lot. Early systems just hashed static values like user agent or screen size, and any small change broke this recognition pattern. Modern ones weight stable signals like GPU and fonts more than volatile ones like time zone, window size, and similar, and allowing fuzzy matching. The latest models compare hundreds of signals to estimate similarity and confidence instead of relying on a single hash, typically using machine learning techniques. What do we mean by device intelligence? It doesn't tell you who someone is, it tells you what kind of environment you are dealing with. It helps you reveal the true intentions behind every visitor, even when they appear completely anonymous. With device intelligence, you can quickly recognize when something doesn't feel right. For example, when a session comes from VPN that doesn't match the device's local time zone, or when someone's hiding behind incognito mode, for example. It gives you visibility to separate normal behavior from suspicious patterns before any damage is done. These device intelligence data points turn raw data into something actionable. They transform static identifiers into a rich context that helps you decide what to trust, what to challenge, and when to act. Let's make this real. I log into my bank every few days, always from my MacBook Pro or my iPhone. The identifier from the bank perspective is consistent. Same GPU, same time zone, more or less same IP range, no VPN, I don't use Tor. I use, most of the time, I'm using quite unique external display, always using up-to-date Firefox, no incognito mode, no automations, no headless mode. And my bank sees that, also together with the same known and trusted identifier. That pattern quietly represents some level of trust. Now imagine one day that these data points suddenly change. Maybe new screen, maybe new operating system resulting in a new identifier. My bank doesn't know what happened, but they know something has changed. The right reaction isn't necessarily to instantly block me. It's to add friction, maybe challenge with 2FA, or temporarily hold of high-risk actions like adding a new payee or wiring money to a foreign account. Or just flag the session for manual review of the anti-fraud team who can call me. This is the invisible layer of trust in action, where fingerprinting lets you adapt, not overreact. In fact, fingerprinting is no longer a niche research paper or theoretical approach. It's a standard part how the modern web understands users and manages risks. When we crawl the internet, we regularly find roughly 1/5 of the all websites, by all I mean like top 10 or 100K, already uses some sort of fingerprinting. And that's just what we can easily detect. Mostly open source libraries like Fingerprint.js implemented in unobfuscated, publicly visible client-side code. In reality, the true adoption is probably much higher. Many organizations build or license proprietary implementations, run them behind gated environment, or obfuscate their client-side code, making it quite hard to see, at least at the scaled level for the crawlers. Fingerprinting and device intelligence exist for a reason, because fraud isn't a small problem anymore. Globally, online payment fraud will cost about $350 billion between 2023 and 2027, according to Juniper Research. That's roughly the size of the Czech economy gone just in online fraud losses. Every year, 50 billion is lost to card fraud alone. That's not theoretical, that's already happening. 16 billion login credentials are circulating in a single aggregated breach database, according to Cyber News. That's almost twice population of Earth, meaning most of us have been compromised several times. And 83% of organizations surveyed by Abnormal Security said that they've experienced at least one account takeover attack. So this isn't about if, it's about how often and how prepared. These are the stakes. This is why identifying devices, browsers, and environments accurately and using that context intelligently matters so much. But here's the twist. The answer isn't always to add more friction. Sometimes the way we try to prevent fraud ends up hurting the good users more than the bad ones. After seeing those numbers, it's tempting to respond with more friction, more FA, more step-ups, more challenges. But that approach backfires. If I log into my favorite app every day from the same device and still face a code or CAPTCHA challenge every time, there's no protection. That's fatigue. And fatigue leads to churn. Device intelligence allows us trust with confidence. If the fingerprint and environment match known history, we could probably let the user in, of course, if they provide additional proof. Some friction, we need to save friction for when context really change. So the real goal isn't maximum security, it's adaptive security. When everything matches what you know, same device, same region, same behavior, don't interrupt. When something changes, raise the bar, step up verification, maybe extra confirmation or manual review. That balance between safety and experience is what defines customer trust. And here's the real question that follows naturally. Who got to decide how much risk and friction are acceptable? You or your algorithms? This is quite an important question in anti-fraud. Most out-of-the-box solutions out there, they try to decide automatically. VPN, block, rooted device, ban. New location, maybe denies access, but fraud is contextual. A VPN might indicate fraud in one business and privacy another. A rooted phone might mean compromises for mobile bank, but a testing environment for a QA engineer. The service should inform, not dictate. Humans should design the logic tailored to the specific business and needs based on the data, and algorithms, they should execute it at scale. Every company's definition of risk is unique. That's why out-of-the-box anti-fraud doesn't work, and generic universal rules can't capture that. Copy-paste models either block good users or let bad ones through. A travel site expects logins from multiple devices and IP addresses. A payroll system doesn't. A QA engineer may run automated tests from emulators, behavior that fintech fraud model would block instantly. Using Tor for wire transfers is quite uncommon in the banking industry, but very desirable and expected for certain journalists or whistleblowers. A generic universal model can't understand your user base, your business, your risk tolerance. And when it can't, it hurts conversion rates and annoys your legitimate users. Fraud detection is about finding patterns that feel almost statistically impossible to be random. For example, a new fingerprint identifier trying to log into the account. Dozens of small transactions from one setup. The same setup tries 50 cards in an hour. Or you see 3 logins from different countries within minutes. Each event alone could be innocent, but together they tell a story. Intent. Device intelligence detects patterns far beyond payments. We've seen clusters of hundreds of real phones running Android, clicking ads, posting fake reviews, or trying to test stuffed credentials. They all share same or similar system levels, identical GPUs, same phones, maybe same WebGL fingerprints. But these aren't humans. They are automated environments designed to manipulate metrics and to do fraud. The moment you can recognize that, you gain massive leverage. From my perspective, a good anti-fraud architecture will work across multiple layers. At the device layer, we protect runtime integrity, making sure the app or browser environment itself hasn't been tampered with. At the edge layer, we act fast and offload pressure. This is often implemented through built-in firewalls or CDN rules, but in reality, is one of the most effective layers against fraud. When done well, it lets you react instantly to emerging fraud patterns without changing code, running deployments, or touching infrastructure. You can define precise rules that block or challenge only what's suspicious, instead of, for example, entire IP ranges. And finally, the backend layer interprets and enforces these decisions in context, aligning them with business logic and risk models. Of course, this second and third layer, they might overlap. It depends on your infrastructure. And yeah, I'll switch to a short live demo now to show how the edge layer can be leveraged in practice, how you can react to new fraud patterns instantly without code changes or redeployments. And yeah, let's try the demo gods. Everyone likes live demos because they usually don't work. So, okay, I missed one more screen, so let's try this profile. Okay, here we are. I prepared this website. It's just dummy login flow. You can sign up. What it does is that it pretty much just sends post requests with the credentials to API/signup. I also got somewhere here code. There's no fingerprinting or device intelligence scripts imported. What it does is it really just sends post to API/signup. And the backend is pretty dummy. It just returns OK every time. What I also did before this presentation is that I deployed a worker to Cloudflare that listens to signup/signup flow and injects fingerprinting script directly into this page. These fingerprinting scripts can generate or help to generate device intelligence. At the same time, I deployed another worker that listens on this API/signup route. And the request is intercepted by the worker. And before it's forwarded to the origin server, it checks the device intelligence. And based on the rules, can manipulate or control flow of the user. So for the demo purposes, instead of tweaking worker in the code, I created also this user representation. So what it does is that it configures behind the scene this Cloudflare worker, and I can tell it that, hey, if you see request where VPN was detected and the location doesn't really match with the locale of the browser, then do something. For the testing purpose, I'll choose something simpler. I'll be detecting just incognito mode, but in reality, you can detect pretty much everything what your device intelligence platforms offer you. Developer tools, Tor, VPNs, various classes of bots, etc. So let's just try to sign up. And I haven't configured anything. And yeah, it works. I received 200. Now let's go to the incognito mode just to test that. I can sign up, and again, 200. Now let's go to this UI presentation and add a new rule where browser and incognito mode is detected that I want to send blocked by device intelligence. Let's save the changes. Changes are propagated within 2 or 3 seconds to Cloudflare. And now when I refresh this and try to log in normal mode, I can log in. And if I try to do the same in the incognito mode, I should be denied. Yeah. So this is just an example, but in fact, you can, as I said, you can build more mature and more mature rules with logical operators to ban precisely what you need to ban or challenge. And you might be wondering, Martin, but hey, I can do that in my backend logic on my servers. And you are right. But if you spot these anti-pro patterns, you probably want to act quickly. So if you want to adjust your backend, you probably need to wake up your engineers, make the code changes, go through the review, deploy it. Maybe we would also need something Terraform. I forgot about testing, etc. So instead of reacting in a couple of seconds, you would end up with a scenario with catching these fraudsters maybe in hours if your systems and processes are mature enough. Let me go back to my presentation. And yeah, device intelligence shows us what's happening. Fingerprinting connects it across sessions. But context is where judgment lives. Fraud prevention isn't about a perfect model. It's about designing decisions that reflect your business values and letting algorithms apply them consistently at scale. So who decides? Your systems can see and score risk instantly, but defining trust, acceptable risk, and friction is still our job as humans. Thank you.
Thank you very much, Martin. Any questions from the audience? I'm happy that the demo worked. It seems like there are no questions.
Yeah, me too.
Thank you. Thank you so much, Martin.
Thank you.